Hello, this is Vasri from Math Home Tuition. Let us do a few problems based on Pythagoras theorem. Here, the first question says BL and CM are the medians of a triangle ABC, right angled at A. Prove that 4BL square plus CM square is equal to 5 times BC square. Okay. So this is the problem. You need to prove this statement. So first let us draw a triangle ABC, right angled at A, right? And maybe this we can take it as B and this as C. Okay. Now they say BL and CM are the medians, right? So let me draw the median. I'll tell you what the median is. Median is a straight line from the opposite vertex to the middle of this opposite side, okay? A line from the vertex to the midpoint of the opposite side is your median. So I'm just going to draw the median here and name it BL, okay? This is my median. BL, and again I have another median which is CM. So from C I have another median to the midpoint of AB, and that is CM. Okay. So what does the median mean? This side and this side will be equal now, and this side AL and LC are equal because L will be the midpoint. Okay. Okay, now you have made the construction. So let me write what is given. Triangle ABC, right angled at A, right? BL and CM are medians. So even that I included in the picture. Now you need to prove 4 times BL square, okay, BL square plus CM square, that is the median square, right? CM square is equal to 5 times the hypotenuse square, which is your BC square. This is what you need to prove. Since it's a median, you can say that L is the midpoint of AC, right? And M is the midpoint of AB, okay? So this is what we have understood from the picture. I'm going to take the triangle ABC, the bigger triangle, okay? ABC. Using the Pythagorean theorem, I can say that BC square is equal to, the hypotenuse square is equal to AB square plus AC square, right? Yeah, AC square. This is by Pythagorean theorem, okay? I just take this as equation 1, okay? Okay, now let us move on to the next triangle ABL, okay? That is because here, see in the question we have BC square here on the right. So that I found out. Okay, now I have to find out BL square and CM square. So for BL square, I am taking the triangle ABL, okay? This time it is ABL. BL square is equal to AL square plus AB square, okay? Now what I am going to do is, this AL square I will change it as half of AC square, right? So it is a half of AC. AL is half of AC square, okay? The whole square plus AB square. So from this I can say that my BL square is equal to AC square over, I'm just squaring both the numerator and the denominator, plus AB square. So just multiplying throughout by 4, I can say that implies, so 4BL square is equal to AC square plus 4AB square. Let us take this as equation 2. Similarly, I am going to do in triangle CMA. Okay, in triangle CMA, we can say CM squared is equal to AC square plus AM square. You can change the AM as AC square, and this AM, since AM and AM is half of your AB, I change it as AB by 2, okay, the whole square. So finally, we would get CM square is equal to AC square plus AB square over 4, right? Squaring both the numerator and the denominator, you get this. So that implies multiplying throughout by 4. I get 4cm square equals 4 AC square plus AB square. Okay, this, let me take it as equation 3. Got it? Now what I do is, I just do the remaining here. I'm going to add 2 and 3. Adding equation 2 and 3, what do I get? 4BL square plus 4, I'm adding the left hand side first, okay? CM square is equal to, here you have 4AC square, just AC square plus 4AB square. In equation 2 you have this on the right, and equation 3 you have plus 4AC square plus AB square, right? So this, I can just take the 4 out in common from the left hand side. So I will have 4 times BL square plus CM square is equal to, you have 5 AC square plus 5 AB square, right? So AC square plus AB square is your BC square. So you get, therefore you get 4 BL square plus CM square is equal to 5, take the 5 common out, AC square plus the AB square is BC square. Okay, so you have proved. Isn't that easy? That's it. Okay. So next question is, 0 is any point inside the rectangle ABCD. Prove that your OB square plus OD square is equal to AO square plus OC square, right? Okay. Now again, we need to solve this, right? You know what is given. Given is the rectangle, and it says that O is a point inside rectangle AC. Okay, should I write all that? Okay. So that is given. O is a point inside the rectangle ABCD. Okay, that is already done, pictured here. Okay, now we need to prove OB square plus OD square equals OA square plus OC square. Let me draw a construction before the proof. So I write the construction here. Draw PQ parallel to BC or AD. Okay, so let me draw that. I'm just drawing a parallel line here. Okay, a straight parallel line which is parallel to your BC. and I name it as P and Q. So since it is a perpendicular line here, you have all these angles 90 degree, okay? So you know that you have 4 right angle triangle there. So let me take one by one and fill in. So let me take POB, okay? What is the equation I can write? I can write my OA square, because we need OA, OB, OC and OD. So I am doing OA square will be equal to AP square plus OP square, right? Okay, so this, let it be equation 1. Oh sorry, it is not AP, it is BP, right? POB, right? So here also it is, sorry, I got messed up. Yeah, so OB square is equal to PB square plus OP square. This I take it as equation 1. Next, let's move on to the next triangle. So in triangle OQD, okay, OQD, it is so simple. You just take each small right angle triangle and just find out the values you need, okay? So this is OD squared is equal to, this is OD, right? It is OQ square plus DQ square. So that is OQ square plus DQ square, and you can put that as equation 2. Then next in triangle OQC, now we are going to take OQ and C, okay? OQC, your OC square is equal to OQ square plus, look at the picture and do. It is OC square, right? OC square is equal to OQ square plus QC square, right? QC square. This is equation 3. And the last equation is, last triangle we are doing is OAB, OAP, right? OAP, where your OA square is equal to AP square plus OP square. So this is equation 4. Now what we are going to do is adding 1 and 2, okay? Adding, I'm just going to add my 1 and 2. Adding equation 1. This is so simple. You just directly end up with the answer. So it is 1 and 2, because in 1 and 2 you have OB and OD, right? So what happens, let me add the left hand side first. So that will be OB square plus OD square is equal to BP square plus OP square plus OQ square plus DQ square, right? So what I am going to do is, I am just going to replace this BP square as CQ square. I just change it to CQ square plus OP, I just leave it as it is, and the OQ also we can leave it as it is, OQ, and this DQ I rewrite that as AD square, okay? AD square. I'll tell you why this. This is because we already know BP is equal to CQ and DQ is equal to AP, right? DQ is equal to AP. Got it? So I just replaced it. Now what happens? I can just add up. When you do CQ square and OQ square, you will end up with OC square, right? OC square. See, remember, CQ plus OQ square will give you OC square. Likewise, if I just add this OP square plus this, it becomes OA square, right? Yeah, that is what we need to prove. OB square plus OD square, right? Okay. So this is what we were asked to prove, and hence it has been proved. I hope this video was useful to you. So see you soon with my next video. Bye till then.